Hi everybody. In the chapter current electricity, in almost all the lectures of current electricity, I have been using Kirchhoff's voltage law and Kirchhoff's current law as they are prescribed by the JEE. Though we call this attributing potential to the nodes, it is nothing but a byproduct of Kirchhoff's law only. I will take a few examples one after the other where usage of this nodal voltages or nodal analysis will become much easier when compared to Kirchhoff's law. This is no illegal method, it's an official method, just that we are attributing potential to nodes of a particular circuit. For instance, you take a capacitor like this, and a capacitor like this. And you have grounded this side. There is no capacitor here is something that I want you people to observe. That makes this problem a bit simpler. They are all identical capacitors. C, and C. Question asked is find the potential here at this junction. Find the potential at O. Find the potential at O. If I try to solve this using Kirchhoff's laws, it becomes a pretty lengthy problem, right? So, what we do here is we will try to, as they asked for the potential at the junction, it makes our life simple if we attribute potentials to junctions and solve the problem. Say, attributing potential to the nodes. If you have grounded something in the circuit, implies the paper setter or the examiner wants you to take that to be zero potential. Right? This will be V as this is V given. This will be V, this will be V, this will be X. I don't know the potential here. This will be potential at O, which I will have to calculate. Always remember, assuming a positive and negative charge is your choice. But once you have made the assumption, stick to it till the end of the problem. If the assumption I have taken here regarding the polarity is wrong, I'll get a negative sign for the charge. Once you have made the choice, stick to it till the end of the problem. Right? Now, basically, we will apply Kirchhoff's current law, KCL. These three plates are mutually connected and isolated. These three plates are mutually connected and isolated. That means charge on these three plates should remain conserved. If charge on these three plates should remain conserved, this is negative charge. This being positive charge implies I am assuming V is at a greater potential than X. So first equation here is because of the negative charge, I will take a negative sign. What is the charge on this plate? V minus X into C. Why will you take V minus X and why will you not take X minus V? Because you assumed this as the positive charge. So this is at higher potential than this. Plus X minus 0 into V plus of X minus 0 into C. X minus, this will not be 0, this will be V naught, my bad. X minus V naught into C is the charge here. X minus 0 into C is the charge here. Net total charge will be 0. V is given to you in the question, the potential of the battery, let me take it as 10 volts. V will be 10 volts. V will be 10 volts. Right? So this becomes 10. So 10 minus X into C is the charge on this plate with a negative sign. X minus 0 into C is the charge on this plate with a positive sign. X minus V naught, sorry. X minus 0 into C is the charge on this plate. Now consider these four plates The negative charge here is minus of x minus 0 into c. The negative charge here is minus of, once and again I am taking this to be 0, this is V naught, which we have to calculate. 10 minus V naught, this is negative plate. 10 minus V naught into C. 10 minus V naught into C. Why will you take 10 minus V naught? Because this side is positive charge. Right? So 10 will be considered to be higher than V naught. Now come over to this plate, plus of V naught minus 0 into C, plus of V naught minus 0 into C should be equal to 0. Let's cross verify the equations again. This is negative charge, so minus 10 minus x into C is the charge, CV. Now this is positive charge plus x minus V naught into C. This is x minus 0 into C. Now come over to this particular negative charge, minus of x minus V naught into C, minus of 10 minus V naught into C, plus of V naught minus 0. This potential is V naught. Don't take that to be 0. V naught minus 0 into C, V naught minus 0 into C. You have two equations and two variables, x and V naught. Eliminate x, you will get V naught. The answer to my knowledge V naught is 4V by 11, 40 by 11 volts. Because you have taken V as 10 volts.